Hi guys! Thank you for dropping by. Today, we're going to visually explore a pattern on how to factor completely a type of polynomial, which is the perfect square trinomial. Before we start, let's recall the pattern on how to square binomial, as this is very important in understanding this factoring technique. So how do you find the square binomial of the form a plus b quantity squared? So first, we're going to square the first term, where we have a times a equals a squared. Then get twice the product of the first and the last terms, where we have a times b equals ab times 2 equals 2ab. Then square the last term, where we have b times b equals b squared. So we have a squared plus 2ab plus b squared, which is a perfect square trinomial. And the first and last terms are perfect squares, and the middle term is twice the product of the first and the last terms. How about finding the square binomial of the form a minus b quantity squared? So again, square the first term, where we have a times a equals a squared. Then, get twice the product of the first and the last term. So we have a times negative b equals negative ab times 2 equals negative 2ab. And then square the last term, where we have negative b times negative b equals b squared. So we have a squared minus 2ab plus b squared, which is a perfect square trinomial, and the first and last terms are perfect squares, and the middle term is twice the product of the first and last terms. Now let's see if you could remember it. So following the pattern is squaring binomial, fill in the missing term. Number 1, we have x plus 2 quantity squared. So blank plus 4x plus 4. What is the missing term? The first term. So what are we going to do to get the first term? Simply square x. So we have x times x is x squared. So the missing term is x squared. Number 2, we have 2x minus 3 quantity squared. So we have 4x squared plus blank plus 9. So what is the missing term? The middle term. So how are we going to get the middle term? Simply multiply 2x and negative 3. So 2x times negative 3 is negative 6x times 2 equals negative 12x. So the middle term is negative 12x. Number 3. 3x plus 4 quantity squared. So we have 9x squared plus 24x plus blank. So what is the missing term? The last term. So what are we going to do? Simply square 4. So 4 times 4 is 16. So the missing term is 16. Number 4, we have 2x plus 3y quantity squared. So we have 4x squared plus blank plus 9y squared. So what is the missing term? The middle term. So what are we going to do? Multiply 2x and 3y. So we have 2x times 3y is 6xy times 2 is 12xy. So the missing term is 12xy. By the way, what is a perfect square trinomial? A perfect square trinomial is the result of squaring a binomial. It has first and last terms, which are perfect squares, and a middle term, which is twice the product of the square root of the first and last terms. So how do we easily identify a perfect square trinomial? So the perfect square trinomial comes in two forms. So we have a squared plus 2ab plus b squared and a squared minus 2ab plus b squared. So the first term, which is a squared, is a perfect square. And the last term, which is b squared, is also a perfect square. So the first and last terms are perfect squares and they are always positive. And the middle term is always twice the product of the first and last terms. Now let's see if you could determine whether the given expressions are perfect square trinomials or not. Number 1, x squared minus 22x plus 121. So checking the first and last terms, so we have x squared, which is a perfect square, and 121 can be written as negative 11 quantity squared since the middle term is negative. And checking for the middle term, so we have x times negative 11 is negative 11x times 2 equals negative 22x, so we have a perfect square trinomial. Number 2, we have b squared minus 8b plus 16. So check the first and last terms if they are perfect squares. So we have b squared and 16 can be written as negative 4 quantity squared since the middle term is negative. And checking for the middle term, so we have negative 4 times b is negative 4b times 2 is negative 8b. So we have a perfect square trinomial. Number 3. 100 plus 50e minus e squared. So, check whether the first and last terms are perfect squares. So, 100 is a perfect square and e squared is a perfect square. However, this term is negative. So, we do not have a perfect square trinomial. So, number 3 is not a perfect square trinomial. Number 4, 40 squared minus 20d minus 25. So the first and last terms are perfect squares, however, the last term is negative. So therefore, this is not a perfect square trinomial. How do we factor perfect square trinomials? Step number 1, examine whether the first term and last term are perfect squares. Step number 2, look at the middle term. Check whether it is twice the product of the square root of the first term and last term. Step number 3, if conditions 1 and 2 are satisfied, then the expression is a perfect square trinomial. And step number 4, factor completely the given trinomial following the pattern. Number 1, if you have a squared plus 2ab plus b squared, then you can factor it as the quantity a plus b squared or a plus b times a plus b. So if the middle term of the perfect square trinomial is positive, then the sign in between the binomial is also positive. And if you have the trinomial a squared minus 2ab plus b squared, then you can factor it as the quantity a minus b squared or a minus b times a minus b. So if the middle term of the perfect square trinomial is negative, then the sign in between the binomial is also negative. Let's try example number 1. So we're going to get the factors 7 squared plus 16n plus 64. So what are we going to do? Check whether the first and last terms are perfect squares. So the first term is n squared and it can be written as n times n, and 64 can be written as 8 squared or 8 times 8. And checking for the middle term, so we have n times 8 is 8n times 2 is 16n. So we have a perfect square trinomial. And writing the factors following the pattern, so the first term is n and the last term is 8. So we have the quantity n plus 8 squared or n plus 8 times n plus 8, which is the square of binomial. Example number 2. So we're going to get the factors of 4x squared plus 4x plus 1. Again, check whether the first and last terms are perfect squares and write them as a square. So 4x squared can be written as 2x quantity squared or 2x times 2x. And 1 can be written as 1 times 1. And checking for the middle term, so we have 2x times 1 is 2x times 2 is 4x. So we have a perfect square trinomial. So writing the factors following the pattern, so we have the first term which is 2x and the last term which is 1. So we have the quantity 2x plus 1 squared or 2x plus 1 times 2x plus 1, which is the square of binomial. Example number 3. we're going to get the factors of x squared plus 14xy plus 49y squared. Again, check whether the first and last terms are perfect squares and write them as a square. So x squared can be written as x times x, and 49y squared can be written as 7y quantity squared or 7y times 7y. And checking for the middle term, so we have x times 7y is 7xy times 2 is 14xy. So we have a perfect square trinomial. And writing the factors following the pattern, so the first term is x and the last term is 7y. So we have the quantity x plus 7y squared or x plus 7y times x plus 7y, which is the square of binomial. Example number 4. So we're going to get the factors of 3x squared minus 18xy plus 27y squared. So check whether the first and last terms are perfect squares. So are they perfect squares? No. So what are we going to do? We're going to think of a number that could divide the terms to make it a perfect square trinomial. So we're going to get the factors of 3x squared. So we have 3 times 1 times x, 18xy as factors 3 times 6 times x times y, and 27y squared can be factored as 3 times 9 times y. So what can you observe? So we have a common factor which is 3, and we're going to use it as a divisor to reduce the given expression. So we have 3x squared divided by 3 is x squared. 18xy divided by 3 is negative 6xy. And 27y squared divided by 3 is 9y squared. So, we have the factored form 3 times the quantity x squared minus 6xy plus 9y squared using the greatest common factor. And now, we're going to get the factors of x squared minus 6xy plus 9y squared. So again, check whether the first and last terms are perfect squares. So x squared can be written as x times x, and 9y squared can be written as negative 3y quantity squared or negative 3y times negative 3y since the middle term is negative. And checking for the middle term, so we have x times negative 3y is negative 3xy times 2 is negative 6xy. So we have a perfect square trinomial. And writing the factors, using the pattern, so we have x, which is the first term, and negative 3y, which is the last term. So, writing the factors completely, we have 3 times the quantity x minus 3y squared, or 3 times x minus 3y times x minus 3y, which is the square of binomial. Example number 5, so we're going to get the factors of 75k cubed plus 30k squared plus 3k. So what can you say about the first and last terms? So they are not perfect squares. So what are we going to do? So we're going to find a number that could reduce the given trinomial. So what are we going to do? Simply factor 75k cubed, 30k squared, and 3k. So 75k cubed can be factored as 3 times 25 times k squared. 30k squared can be factored as 3 times 10 times k, and 3k can be factored as 3 times 1 times k. So what can you observe? We have common factors. So 3 and k and 3k is our greatest common factor. And we're going to divide it to the 3 terms. So we have 75k cubed divided by 3k is 25k squared. 30k squared divided by 3k is 10k, and 3k divided by 3k is equal to 1. So we have the factored form 3k, which is our divisor or the GCF, times the quantity 25k squared plus 10k plus 1 using the greatest common factor. And now, we're going to factor 25k squared plus 10k plus 1. Again, check whether the first and last terms can be written as a square. So 25k squared can be written as the quantity 5k squared or 5k times 5k. And 1 can be written as 1 squared or 1 times 1. Checking for the middle term, so we have 5k times 1, which is 5k times 2 is 10k. So we have a perfect square trinomial. And writing the factors following the pattern, so we have 5k which is the first term and 1 which is the last term. So writing the complete factors, so we have 3k times the quantity 5k plus 1 squared, or 3k times 5k plus 1 times 5k plus 1. Are you ready for a challenge? So challenge number 1. What are the factors of the trinomial y squared plus 20y plus 100? The answer is y plus 10 quantity squared, or y plus 10 times y plus 10, and you are correct. Challenge number 2. So we're going to get the factors of k squared minus 8k plus 16. So the answer is k minus 4 quantity squared, or k minus 4 times k minus 4, and you are correct. Challenge number 3. What are the factors of 16m squared minus 48m plus 36? The answer is the quantity 4m minus 6 squared, or 4m minus 6 times 4m minus 6, and you are correct. Well, that's all for today. I hope you learned something. So if you did, please hit like and subscribe. Thank you for watching.